Hey y'all, I wanted to continue our conversation today with the final operation that we're going to talk about, dividing radicals. We've talked about adding and subtracting already. The other day we looked at multiplying. Now let's look at dividing. So, dividing terms and expressions with radicals is represented in fraction form. To simplify, we can follow these steps. The first step is that we want to simplify the fraction if possible. This means that we could simplify coefficients and or the radicands. So we could either simplify the terms that are in front of the radicals, or we could simplify within the radicals themselves. And I'll show you what that looks like. Step number 2, and this is kind of the new step that I'm teaching here, is if we've simplified already and there's nowhere else for us to go, we are going to multiply the top and the bottom by the radical in the denominator. So we're going to multiply the top and the bottom by whatever the radical is in the denominator. And then the third step is to simplify wherever possible. The overall goal there should not be radicals in denominator. I'll just abbreviate that DEN. So there shouldn't ever be a radical in your denominator if you have simplified an expression correctly. So let's look at a few examples here. Example 1, let's do the square root of 8 divided by the square root of 4. Now, notice that both of these terms are represented in fraction form. I have a radical in the denominator, and I have a radical in the numerator, actually. Now, if we look at our first step, where we're going to simplify coefficients and or radicands, because both of these are inside of our radical here, I can actually simplify these numbers against each other. So if it's 8 over 4, if I divide both by 4, that gives me 1. This would give me 2. So without even having to multiply anything, I get the square root of 2 over the square root of 1. And the square root of 1 is just 1. So that would be the square root of 2 over 1. Or we could just leave it as the square root of 2. So this one was pretty quick to simplify because both of the radicals were able to factor against each other. Here's another example, example 2 here. This one a little bit bigger, so 6 square root of 10 over 3 square root of 5. Now, in this problem here, I actually have 2 different ways that I could simplify. I could simplify the coefficients first. So like 6 and 3, if I divide those both by 3, I get 1 and 2 here. So I'm going to have 2 and 1 here as part of my answer, or as I'm working. And then for the radicals, 10 and 5, if I divide both of those by 5, this becomes 2, this becomes 1. So this is square root of 2 and square root of 1. But then if we look at simplifying that, that would be 1 times 1, because the square root of 1 is 1, which really is just 1 in the denominator. So that means that it's 2 square root of 2 on top. There's nothing to simplify with either of those. Square root of 2 doesn't simplify. So I get 2 square root of 2 over 1, or just 2 square root of 2. Now, both of these examples, I've given you ones here where you could simplify your coefficients and your radicands first before you really started the problem or the process of canceling out a square root in the denominator. Now, for this next example, we're not going to be so lucky. So square root of 8 over the square root of 3. Now, 8 and 3, they're not factors of each other. 3 doesn't go into 8 evenly. So I can't simplify this quite yet. So what I'm actually going to do is I'm going to multiply the top and the bottom here by that radical in the denominator. So multiplying square root of 8 times square root of 3. And then the bottom is going to be square root of 3 times square root of 3. So what happens is I get a square root of 9 on the bottom. And then in the numerator, I get a square root of 24. Now, for those of you that might have caught it already, the square root of 9 is 3. So really what happens when you multiply a square root with the same radicand by itself, it just cancels out the radical. So like, for example, square root of 4, actually bad example, square root of 5 times square root of 5 is 5, because it'd be square root of 25, which turns out to be 5 when you break it down. Now, this square root of 24, I could simplify that. Maybe I'll do that off to the side over here to show you my work. So square root of 24, that becomes 4 and 6, which is 2 and 2. So these 2's are going to come out. That 6 will be left. So that gives me 2 square root of 6 here. And there's nowhere really else for me to go. I can't simplify anything. Now, a lot of times students will look at this, the 6 and the 3, and they'll say, well, 6 is divisible by 3, but one is inside of a square root and the other is not. So you can't simplify those. They're not able to cancel out each other. So this is actually your answer that we should come to. 2 square root of 6 over 3. Let's do another example, one that's a little bit longer here. I have 5 over 3 square root of 2. Just like in the last problems, we would look to see if we can simplify anything. We can't quite yet, so I'm going to multiply by the square root of 2 to the numerator and multiply square root of 2 to the denominator as well. I get 5 times the square root of 2 in the numerator, and then in the denominator I get 3 times the square root of 4. Now let's look at the denominator, because 3 times the square root of 4 really is 3 times 2, because square root of 4 is 2. And then this numerator doesn't really simplify, 5 square root of 2. So we have 5 square root of 2 over 6. And that turns out to be our final answer, because 5 and 6 don't simplify, and I wouldn't simplify the square root of 2 against 6 because one's inside of a square root, one's outside of a square root. One last problem, and this one's going to be one of the more challenging types of problems that you will see, just because there will be a bunch of steps here within simplifying multiple times. So we have 5 square root of 8 over 3 square root of 6. All right, so from the get-go, we can see that 8 and 6, I could simplify those a little bit if I divide them both by 2. So I'd have square root of 3 and square root of 4 here. So Let's write that out. We have 5 square root of 4 over 3 square root of 3. Now, some of you might simplify the square root of 4 right away to be 2 and turn that numerator to 10. That's totally fine. I'm just going to keep going with getting rid of this radical in the denominator. So multiply this by the square root of 3. Multiply by the square root of 3. And I'm only going to multiply by just the square root of 3, not 3 square root of 3, because I'm only trying to cancel out that radical. So we get 5 square root of 12 here, and then over 3 times the square root of 9. Be careful not to simplify your radicals now. Like, don't say, well, 12 over 9 simplifies to 4 over 3, because then you're just running in circles. Instead, I would look at this as, well, I have 5 over the square root of 12 over 3 times 3, because the square root of 9 is 3. So I'm gonna shift this down a line here. So 5 square root of 12, that's bad, 12, over 6, essentially what happens. But I can't leave that as square root of 12. I do need to break that down. So square root of 12, that's 4 and 3, which is 2 and 2. So there's my pair left over 3. So this becomes 5 times 2 square root of 3 over 6, which is 10 square root of 3 over 6. And then, I know, one last step. 10 and 6, those would cancel out. So if you divide them both by 2, you get 3 in the numerator, or denominator, and 5 in the numerator. So we get a final answer of 5 square root of 3 over 3. And there you have it. This would be our final answer. So this was a quick lesson on how to simplify expressions that are represented with dividing radicals. There will be a homework assignment posted for you. As always, make sure you email me if you have any questions. Copy this down into your notebook, and I will see y'all in class the next time that we meet.